Hello everybody, I will start my today's another live coding session. So in my today's session, I will solve this question. Longest increasing path in a matrix. So in this question, I'm given an m by n integer matrix, and I will return the ranks of the longest increasing path in matrix. From each cell, you can either move in 4 directions, left, right, up, or down. You may not move diagonally or move outside the boundary. Wrap around is not allowed. Okay. Yep. So, yep, quite simple. So, in this question, I'm giving a matrix n by n, and I will look, yep, and this is the integer matrix, and I will look for the longest increasing path in matrix. So, for example, 1, um, the longest path is 1, 2, 6, 9. Yep, indeed, this is increasing. And obviously, I cannot choose 1, 1, 2, 6, 9 because 1, 1 is not increasing. Yep. So the path has to be strictly increasing. Good. Okay. So that being said, I will quickly. Oh, and the out of this the output of my function would be the length. So it is an integer. Okay. From the constraint, I can find that m and n is 1 to 200, and each number in the matrix is 0 to the power of 31 minus 1. Okay. So I've confirmed the question statement and also input and output. So I will look at this question with an example. Yep. With this example, I think the brute force approach is that I will start from each each cell, and I do the DFS, and I will try as much as I can go, and then for every termination point of the DFS, I will find out the length of the current path from the start cell to the current cell. Then I will do this DFS from each cell and for every possible path, and I will return the maximum one out of the found path. So in this way, I think I will quickly estimate the time complexity upper bound. So the loose upper bound is that I will have m start, and for each I have 3 directions remaining. Yep. And I can find, yep, because I have mn minus 1 choices, the time complexity would be like this. Obviously, this is the upper bound because the remaining direction from each cell is, decreases from 3 as I go through. So I said this is the upper bound. Yeah. But even that being said, this is too much. Yeah. So I will think of a better approach. So I think I can use the top-down DP for this question. So, for example, if I take a look at this cell, for each cell, I can say so if I'm at this cell 6, yep, I will take a look at 4 directions, and I can say this may come from here, 9. No. or 6 cannot come from the left adjacent 6, or 6 cannot come from, adjacent 8, but 6 comes from 1. It is possible. So I can say the maximum length of the path which ends at this cell 6 is 1 plus the maximum length of the path until 1, which is at the bottom. Yep. And I can say it's right if there is like 3. Yeah, for example, in this case. So if this is 3, now it can come from this 3. So the maximum path which ends with this 6 is the maximum. Okay, there are 2 paths. One path is in which 1 to 6. And the other path is 3 to 6. And I will compare the paths of these 2 possible, directions. And the bigger one, larger one, is the maximum length. So I can say this is a kind of equation like this. Yep. So this is a kind of DP equation I can use to solve this question in a dynamic programming way. Yeah. And one more thing I can say is, obviously, and I can use the memorization because for each cell, once I calculate the maximum length, path length, I can use it again and again. I don't have to do the redundant computation. I will use the memorization. Yep. And quickly, I will think of the base case. The base case is that, for example, this one, there isn't any number which is smaller than this number, 1, which means that this is the start of the path. This cannot be the, there isn't any cell which comes into this 1. This is the base case, and I can say in this case, the path length is 1. Okay, so that's an approach I can use on top-down dynamic programming. So for time complexity, it should be Mn because this current cell, possible candidate of this current cell is M by N. Yep. And for each, the, time complexity of this recursive function takes only the constant time. I just have to take a look at 4 adjacent cells and do some math. I just do some, comparison. Yeah. So aside from, excluding the time complexity for the recursion call, the time complexity of each recursive function is O of M, over 1. So in total, the time complexity should be O of Mn. For space complexity, this is exactly the, space for the cache, memorization cache, and also space for the recursion stack. For cache, because there are Mn, argument of this recursive function, it should be Mn. Yeah, the cache is the key-value pair, and there are Mn keys. And for value, it's just an integer length, so it should be, Mn by 1 is Mn. And for recursive function, I can think that the worst case is that something like this. So, if I start from here, then I will try to do recursion until 987645321. In this case, the number is decreasing in zigzag order. In this case, the recursion stack should be mn. Yep. So that's the worst case space complexity for the recursion stack. So in total, this should be OMN. Okay, that being said, I will start the implementation. Okay, so this is it. Oh, so I implement something aside from the recursive function. So I will quickly tell you what I do in the current code. So firstly, in line 30, I initiate the global max ranks, which should be eventually returned, because I can always find the max length one, because I just have to take the only single cell that initiated this global max ranks is one. And in line 32 to 34, I start from each cell as the end point, end cell, and I, find out what's the max ranks of the path which ends with that end row and column cell. Then I get the maximum of such local maximum ranks and update the global maximum ranks and return it in the end. Okay, now I will implement the recursive function. So I'd like to access this end rows and end columns, so I move it before the local function. Okay, so this is it. So in this recursive function, um, yep, I will initiate the return value, which is a max length, with 1. Because as I said, just like as I said before, I can always find the length 1 path, which is just by taking the current cell only. So that's the initial, value of a returned read. And then I will take a look at 4 directions for adjacent cells, prev row, prev column. Yep. Then in line 35, if prev row, prev column is out of the board, I will skip it. And in line 38, if prev row, prev cell, prev column is, the previous cell is not smaller than the current cell, I will skip. And otherwise, in line 41, I update the returned max length with, max length of, I do the recursive function call and then get the maximum length under the previous cell, and I increment it by 1, and then I get the current max length. And I will update the read with that. And in line 43, after taking a look at 4 directions, I return read. Okay, so it's a simple implementation. So let me quickly walk through my code with a very simple example. Okay, so I will use this example. Okay, so in this case, end rows begins with 2 and end columns it's initiated with 2. Okay. And in line 54 and 55, end row and column is initiated with, 0, 0, 0, 1, 1, 0, and 1, 1. So I will take a look at these 4, cases in these 4 iterations, for loop. So firstly, in the case of 0, 0, I call the max length function with 0, 0 here. Okay, then read is initiated with 1, and firstly in line 39. Okay. So again, I will list every possible prev row prev column combination first to save my time. So because I row column is 0, 0, okay, prev row prev column could take these 4 combinations. Okay, so in line 44, I will take a look at, for the first case, 1, 0, prev row, oh, I found a mistake. It should be like this. Okay. So prev row is between 0 to 1, yes. And prev column is between 0 to 1, yes. So I go to line 47 and matrix prev row prev column 1, 0 is 2. So this is not, so this is current cell is 1. So this is true. So I skip. I go back to line 38, and the next case is negative 1, 0. Because this is out of the cell, I skip. And for 0, 1, because this is inside of the cell, I will take a look. So in the case of 0, 1, in line 47, the comparison should be this, not 1 smaller than 1. And this is true. So I continue. Then I come back to 0 minus 1. So this is out of the cell. So this is kept in line 45. And finally, I return 1, not updated. Okay. So this is tier 1. Yep. Okay. In this way, I will take a look at 0, 1. And in the same reason, this doesn't update read. Yeah, I will skip something which is obvious because I've already, I have to save my time. Okay. Then I will take a look at 2. Yep. Something becomes interesting from here. So when the case of 1, 0, pre-row prev column should be something like this. And out of this, only 0, 0. Okay, so 2, 0 is out of the board. And 0, 0 is something interesting. So I will take a look later. For 1, 1, with this one, 1, 1 is 3, which is larger than 2. So this is skipped in line for 57. And for 1 minus 1, this is skipped because this is out of the board. So I will take a look at 0, 0 case. So in this case, in line 59, max length of the 0, 0 is 1, which is already calculated. So I update the read with 2. So in the end, I return 2. Okay. So now read is updated with 2. Yep. And in the same way for 1, 1, if so in line 769, if I start with end row and column 1, 1, in line 52, possible, preview row prev column is like this. Yep. And for 2, 1, this is out of the board. For 0, 1, this is something interesting. So I will take a look right there. For 1, 2, this is out of the board. For 1, 0, this is smaller than 3 because 1, 0 is number 1. Okay, so I will take a look at the 0, 1 only in line 60. And because 0, 1 is, max length 0, 1 is 2, which is already calculated. So I update read with 2 plus 1 is 3. So 3 is returned. Oh. Yep. So in line 70, global max length is updated with 3. And I will return 3. Yep. This is exactly what I expect. Yeah, 1 to 3 is the maximum increasing path length. So I return 3. Okay, good. So now I'm pretty confident in my code. I covered all the lines of my implementation. So I execute my code. Great, accepted. Okay, so I will quickly wrap up on today's coding practice. So in my today's session, I solved the question, longest increasing path in the matrix. So in this question, I'm giving an m by n integer matrix, and I will return the ranks of the longest increasing path in the matrix. And For this question, I use the top-down dynamic programming. So basically, the you know DP equation is for each recursive function, the argument is each cell. And from that cell, I will return the maximum length, which ends with that cell. Yep. And to think to calculate that, I will take a look at the 4 adjacent cells, and for each cell which is smaller than the current cell, I will get the maximum length until that cell. Then I add yep. Then I increment it by 1 because the current cell is appended to the end of that cell, end of that path. Yeah. And I will calculate the maximum path length from each third direction if possible. So the maximum one out of these up to 4 paths is the maximum longest increasing path, which ends with the current cell. Yep. So in this way, I can calculate the maximum length path for each cell recursively. Yep. So yeah, that's how my recursive function works. And obviously I can memorize, memorize the result in the cache, keyword cache. Yep, that's it. In that way, I take a look at each possible cell as the termination point, termination cell, and I guess the maximum length until the cell, and I return the maximum out of this mn result. Yep. So in this way, I could solve this question in O of n and mn time complexity. Okay, thank you so much. So that being said, I call it a day today. Thank you.